Hey there! Today, we're going to explore a cool math concept called integers. Imagine it's a chilly morning, and the temperature is at 0 degrees Celsius. Suddenly, the sun comes out, and the temperature jumps up by 5 degrees. But as the evening arrives, it gets colder, dropping by 10 degrees. How do we talk about these temperature changes? That's right, with integers. Let's dive in and discover how integers help us describe the world around us. Integers are like the building blocks of numbers. They include all the whole numbers that are positive, like 1, 7, and 18, all the whole numbers that are negative, and also the number 0 like -3 and -5. So, -3, -5, 0, 1, 7, and 18 are integers. But numbers like 1.6, 1.5%, or -2.43? Nope, those aren't integers because they are not whole numbers. Integers are simple and neat, only whole numbers allowed. Let's break down integers a bit more. Negative integers are numbers less than 0, like -3 and -5. 0 is super special because it's neither positive nor negative. Then, we have positive integers which are numbers greater than 0, like 1, 7, and 18. So, integers can be negative, 0, or positive. Pretty straightforward, right? Imagine a straight line where each point represents a number. This is called a number line. 0 sits in the middle, not picking sides. To the left, we have negative integers getting smaller and smaller, like -1, -2, -3, and so on. To the right, we have positive integers getting bigger, like 1, 2, 3, and so on. Fun fact: in a number line, numbers are arranged from left to right in increasing order. Let's plot a number. How about 4? Since 4 is a positive integer, we move to the right of 0 on the number line. We count 4 steps to the right and place a dot. We have successfully plotted the number 4. Now, what if we want to plot -2? Since it's a negative integer, this time we move to the left of 0. We count 2 steps to the left and place a dot. And just like that, -2 is plotted on our number line. Let's see the next topic, which is properties of addition and subtraction of integers. First, let's see what is closure under addition. When we add two integers, guess what? The result is always an integer too. For example, if we add 17 and 23, we get 40. All of these are integers. The same goes with subtraction. Closure under subtraction. If a and b are two integers, then a minus b is also an integer. Like, 7 minus 9 is equal to -2, which is also an integer. Commutative property. When adding integers, it doesn't matter which one comes first, the result is the same. A plus b is always equal to b plus a. However, subtraction is a bit picky. The order matters because subtracting one integer from another doesn't give the same result if we flip them around. So, a minus b is not same as b minus a. Addition is flexible, but subtraction likes to follow the rules. Associative property. The integers can be grouped in any manner to get same result for both addition and subtraction. Additive identity. When we add 0 to any integer, we get the same integer. So, 0 is called the additive identity, and a plus 0 is equal to a is equal to 0 plus a. Now that we have learnt about addition and subtraction, let's see multiplication of a positive and a negative integer. While multiplying a positive integer and a negative integer, we multiply them as whole numbers and put a minus sign before the product. We thus get a negative integer. Multiplication of two negative integers. The product of two negative integers is a positive integer. We multiply the two negative integers as whole numbers and put the positive sign before the product. Let's see the properties of multiplication of integers. Closure under multiplication. Guess what? Multiplication with integers always ends up with an integer. It's like a magic trick that never fails. Commutativity of multiplication. You can multiply them in any order, and it's all the same in the end. It's like a teamwork dream where everyone works well together no matter what. So, A multiplied by B is always equal to B multiplied by A. Associativity for multiplication. The product of three integers does not depend upon the grouping of integers, and this is called the associative property for multiplication of integers. Distributive property. When multiplication meets addition or subtraction, it likes to spread itself out, making sure every integer gets a turn. This is called the distributive property, and it's like sharing your snacks evenly with your friends. Everyone gets an equal part, making it fair and square. Now, let's move on to division of integers. When we divide a negative integer by a positive integer, we divide them as whole numbers and then put a minus sign before the quotient. When we divide a positive integer by a negative integer, we first divide them as whole numbers and then put a minus sign before the quotient. Let's see the properties of division of integers. Division has its own set of rules. Division is not commutative for whole numbers. -8 divided by -4 is not same as -4 divided by -8. Any integer divided by 0 is meaningless, and 0 divided by an integer other than 0 is equal to 0. Any integer divided by 1 gives the same integer. Let's go back to our temperature example. From 0 degrees Celsius, the temperature increased by 5 degrees in the morning. In the evening, it decreased by 10 degrees. How can we represent these values using integers? The temperature rose by 5 degrees, then fell by 10 degrees. Using integers, we can say it went up to +5 and then down to -5 degrees. Integers help us describe these changes neatly and simply. To wrap up, let's recall and try to answer these questions. What is an integer? How do you plot integers? What is one application of integers in real life? Also, there is an answer key waiting for you, and here it is. We hope that you have understood the topic. You can now study chapter notes, watch video lectures, and solve MCQ tests of this chapter on EduRev to ensure you score well in your school exams. And that's not all, you also get amazing courses for maths, science, English, Hindi, and much more for Class 7. Thank you.